Yeah, Gajanan, you are the host now. Over to you.
Sorry.
You are the host now. Over to you.
Yeah, I got your point. So the thing is, everyone is able to join this link, or how is it?
Yes, yes, everyone joined this link.
I think only 3 attendees are there. Is somebody expected to join?
I'll just check with the mentor and get back to you.
Sure. Thank you so much. Guys, how many usually join for the session? Only 3? Okay. 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 Allow to talk. I will just make it allow to talk, everyone. Allow to talk. Yeah.
Yeah, can you hear me now?
Yes, I can hear you. Yeah.
Yeah, last time we had 4 people, I think, for this group to join.
Only
Yeah.
for
Yes.
Yeah, in the last group call. Yeah.
But the fourth one also joined late, and then he like probably was having network issues, I guess.
Okay, okay. I think we'll wait for only 2 minutes and probably we'll start. Okay. Is this fine with you?
Sure.
Yes,
Okay.
okay.
Thank you so much. I think probably we'll start. So, okay. So let me introduce myself first. I'm Gajanam Kulkarni. I do have 7+ years of experience overall. Out of 7 years, I do have 2 years in teaching and rest as a industry experience. So I worked with many of the MNCs, and if we are talking about the technology stack, I worked on Java, .NET, uh, the Angular, that is your technology again, and a bit of React. The databases I worked on, the Oracle, MySQL, SQLite database, which is a file-based database again. I am very fortunate enough that I got opportunity to play a main role. That I worked as a Scrum Master, product owner. I was part of requirement gathering team to, if new products comes to our plate, then we have to first gather the requirement from the end user or the business and what exactly we need to, give it back, that we need to understand. Okay, so I was part of that requirement gathering team as well, and as a Scrum Master, as I already told you, right? So I done my masters in, master MTech in electronics. So after that I moved to, the software industry. So I think that's it from our side, is from my side. So can you please introduce yourself? So in introduction, we'll just, go with a little brief. Okay, so your name, your background qualification. The third is, currently if you are working, and don't tell the name as well. I'm not bothering on that front. And what you expect from upgrade. So shall we start on that? We'll start with Yogesh, and I will just make a note of it as well.
Sure. Hi, everybody. I'm Yogesh. I did my BTech in Electronics and Communication in 2011, and since then I'm been working. Initially started with embedded domain and now currently working in networking domain. So from upgrades course, my expectations are um, first and foremost to get more qualification in a sense of things which I couldn't learn. For example, the newer technology is like cloud computing and all. So that is why I'm doing this diploma. And if I get an opportunity further, I'll pursue for masters as well in software development, which is my plan. And with this immediate boot camp, as we all know in software industry, data structures or algorithms is very important, and I don't think I am that good in that. So my current emphasis is on that to learn as much as I can. Yeah.
Okay.
Thank you.
Okay. Thank you, Yogesh. Then we'll move to Biju.
Hi, Biju here. So I did my bachelor's in computer science and have around like 13 years of experience fully on the software testing. So the primary goal of me choosing this master's in computer science is to more learn about the full stack development. So once I get this knowledge, maybe like look to learn newer technologies. So first I want to get my base correct. So I want to learn this full stack development.
Okay, super. Then we'll move to Bharadwaj, Rohit.
Yeah, hi, my name is Rohit. I have around of 6 years of experience in support roles. So like, and my main target is to move into development roles. So that is the reason why I have chosen this.
Okay.
I
So
have
support
basic.
means
Hmm.
what exactly? It's a product support, or it's, the which kind of
I,
support?
it's an application support. So in the firm that which I work, so there is 3 teams, L1, L2, L3. I am in the L2 team. So major of the
Okay.
things are Jiras that are raised. We look primarily into the issue, and if it is something that we can resolve, we do it. Otherwise, we pass on to the L3 team.
L30. Okay, sounds good. Thank you, everyone. So the thing is, I think with you it's my first session, but we already had a couple of sessions with other groups, and it went amazing. So my primary goal is not to give the theoretical knowledge, what exactly we are working in the industry and how we can implement our knowledge in our industry. That I will focus more. Okay. So with start with this session, we'll divide this session into 3 segments. Okay. The first segment is nothing but, uh, I do have one presentation, so I will just try to present in front of you along with some of the actual coding and the calculation stuffs. That is nothing but with respect to the DSA. The second part is nothing but with respect to the MCQs. Okay, so I think okay, before that, can you please brief about what exactly you have learned in the last week? I am interested in that as well.
Yes,
For
of course.
me, what I
We
have,
will start one by one. We'll start with Yogesh.
In the first week of bootcamp, that is data structures. The module was regarding algorithms and its complexities. But
Okay.
what I could see from the module sessions and everything, the more or less emphasis was on the recursion. Many
Mm-hmm.
of the questions and programs which we saw, and like master algorithm also which we use to find the complexity was mainly focused on recursion. So that is what I felt. Yeah.
Okay. Okay. Fine. Biju.
Yeah, so I didn't fully complete the learning yet. I still need to do quite a few. I just finished one first segment alone. So based on my understanding, so I know like how to calculate the time complexity of this big O
Mm-hmm.
notation and theta and the sigma. I need to go through the
Mm-hmm.
remaining segments.
Okay. 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 Thank you. Rohit.
yes, for me also almost similar. Like I have been through all the three notations that are used.
Mm-hmm.
There is some doubt in the big O part, like how
Mm-hmm.
do we calculate for constant numbers?
Mm-hmm.
That I might ask you later in the session. And
Okay. Sure. Mm-hmm.
regarding algorithms, I had one doubt, like why do we choose recursive over non-recursive when we always see that the non-recursive ones are faster? Like
Mm-hmm.
that's one thing I had a doubt as of now.
Okay. I will just make a note of it.
Except for saving some few lines of code, I do not see much of a benefit in
Okay.
recursion.
Sure. 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 So, okay, we'll clear all your doubts, whatever I can do. Okay, so fine. So we'll start with this session. The first thing, let me clear you from my side. So the thing is, I just kept it as simple as I can, and I will emphasize more on the practical things. So how we exactly use algorithm in our real-time scenario, or what exactly how we will see the performance of our application, what are the parameters that will impact to any of the products, and how the user experience will deal with these products. Okay, we'll start with basic things. I will just share my screen. If you have any doubts, you can just interrupt me and you can throw your questions. Okay, so fine. Okay, so before that, in your last sessions, how exactly you're learning? So it's kind of presentation, or the practical stuff, or it's kind of the combination of both.
It
We
was
had both. We had
Okay, perfect. Then yeah, we'll do the same kind of. Okay, so yeah, we'll start with algorithm analysis. Okay, so first step is, what is algorithm? Okay, so it's just a set of rules obtained to, so this is just this is the formal definition, or I would say a bookish definition. Yeah, even though this is very, very important, whenever you are going for any of the interviews, you need to give the formal definition. But the thing is, what exactly inside this? Okay, the set of rules to obtain the expected output from the given input, that is nothing but the algorithm. And the algorithm is, to solve any problem, we must concentrate on time consumption and the memory. So that comes the time complexity and the space complexity. Algorithm should have language independent. Yes, definitely. When we are talking about the algorithms, it should be the language independent. It should be reliable, and the very defined inputs and output. What exactly you are providing for for the middleware that you want the respective output. That is nothing but you should always keep it in mind that you should have well defined inputs and the outputs. Okay, so before that, I just wanted to give you a good example why the algorithm is very necessary. I will just give you one short story. Okay, so you heard about World War II, right? So the German and they in World War II, what usually German people do, they are sending the AM radio signals. Okay, so AM radio signal they usually send to connect with their troops. Okay, what happens generally? So if somebody has a knowledge of how to decrypt it, then he can do it with some of the algorithms. Okay, that time that was the Moore's algorithm they used to have. So what happens generally, if the interpreter are there and they are easily able to decode the whatever the sending message, whatever the Germans used to send the message, and later what they realize that our message has been decoded. So that's why we need to change the algorithm, or in such a way that we should have daily changes in our messages. Okay, the encryption algorithm we can change it. Okay, so they did like that, but unfortunately, the whoever tries to decrypt it, they are unable to decrypt it. Then laterly, in British military, the Alan Turing was the person. Okay, he had joined the British military, and he was trying to took a judgment that with pen and pencil it's not possible to decode this message. Okay, then he tried to implement the algorithm, but unfortunately due to daily changes in their the sending the message packets, he was unable to find, or he was unable to decrypt the daily message. So after that, after some time, or maybe some days later, he realized that with every message at the end of that, they were sending that Hell Hitler aha. So that was the stream, or that was the string they are appending to each message. Okay, that pattern he got it, and he developed one algorithm, and he found whole message. He used to decrypt the message, and that's why he stopped World War early. So it has been the drastic, I would say, that change is really very big, so it saves many lives. So that was the power of algorithm. Okay, so algorithm he has developed such a way that once he got exactly what is the core of this message, and he developed it and he encrypted. So that's why the World War stops early. So likewise, World War algorithm is used to save many lives. Another one example is you are aware of the Google engine. So Larry Page, who is a co-founder of Google with Sergey. Okay, so these two people has developed PageRank as an algorithm. So we usually have the search engine in our Google, right? So they do have their PageRank as an algorithm. Okay, so the algorithm is very powerful. That right now, if you see the day count for page hit on the search engine is around 2 billion. You can't believe it. Okay, so that is nothing but a very huge amount of people are surfing on the Google search engine. So that was it will not beat the Bing or the other search engine. So that was the power of algorithm. And when we are talking about the analysis of, this is the again formal definition, a major amount of time for an algorithm to execute. So okay, I don't don't care of this one. Okay, but let's take what is meant by analysis in our real-time scenario. So can you just we'll make this interactive session, right? So what is meant by analysis? Can somebody tell me? Generally, the what is meant by analysis we usually do, right?
See the
Uh,
pros and cons of it, of like whatever we are selecting, what will be the outcome, how is it going to be, kind of that.
Okay. Any more inputs?
yeah, similar,
Yeah,
like to find a solution to the problem, like we might do some research, like the steps needed. That can be a part of analysis.
Okay. Any other thing?
It is kind of trying to learn more about the actual process.
Okay. Okay. Again, I don't want to see these things. Yeah, this is definitely it's a this sentence will state you what is meant by analysis. The measure of amount of time for an algorithm to execute, means how much time does it take, or okay, let it be. So I will just tell you, when we are developing any product, okay, so the first and main part is the performance. Okay, so what is meant by performance analysis? We do have one term, right? Performance analysis. Let's take, I will give you one basic example like Facebook. Okay, in Facebook we have the profile picture. Whenever you click on the profile picture, let's take it takes me 5 seconds to download it or to view it. Okay, so that is a very bad experience, that user will say that every time if we are I'm hitting to the profile picture, it is taking 5 times to reload it. Okay, so that is not the good experience, so that's why you are degrading your product quality. Okay, let me demonstrate you one basic thing. Okay, so I will just what I will do, uh, everyone should know what is meant by inspect. Okay, so inspect means we are just seeing over here. What I will do, I will just say google.com. Okay, so if you see this google.com, okay, in headers, this is the URL https www.google.com. okay, and this is the get request, right? So what we are doing over here, we are it's an endpoint, we are hitting it with a get request, we are getting a 200, that is http okay request, okay response. Okay, so the thing is, if we are talking about the performance, we can see within 1.31 seconds I'm able to render it. If you go to the timings, everything it has been divided into the segments, that request sent, waiting, and content load. So these are the time duration to load whole page. So that is nothing but 1.31 seconds. Okay, guys, this is very important when you are working with real-time project, right? So sometimes it happens that we need to improve the performance of our product. Then we need to take it into the consideration that what are the rest endpoints, what are all rest endpoints consuming the timing. So using this we can see it. Okay, and if you see this one, 1.4 MB. Okay, so this is nothing but resources loaded by the page. So this page does have the labels, does have the JavaScript content, or maybe we can see it over here as well. If you see the response, we have this one, this doc type is HTML5 again, and we have different URLs, we have the functions, we have the if you see we have CSS as well. If you see to header, if we just go to inspect and we see over here, we have different CSS already associated with this. Okay, so with respect to that, it is taking very less time to render it. But yes, again, there are different parameters to associated with this. Let's take what are different parameters are affecting to render this page. The first thing is our internet speed, that is also matter, right? And whether you are surfing on incognito mode or normal mode, that also matters, because in incognito we are not storing the the history or the cookies kind of, right? So these all are depend on different factors. So whenever you are developing any product, you have to keep in mind all these things. That is nothing but we have analyzed this page, that how much MB it has been consumed, or how much time response time does it needed. Again, the security stuff application, that is again in depth of that. Okay, but the thing is, analysis is nothing but, as we said, the algorithm, how much time does it take. It's not only the time, it's the space required for that, everything. Okay, now we'll move to, yes, my favorite question, a difference between algorithm and pseudocode. Does anybody have an idea? What is the difference between algorithm and pseudocode?
Pseudocode is like English word steps for coming to a solution. An algorithm will be like more code specific kind of thing.
Okay, good. Mhm. Any other input?
My understanding is that first step is the algorithm, and
Mhm.
then maybe you go for the pseudocode. Like pseudocode is based on algorithm what you infer. So you just write it down, and then you go for actual coding.
Okay. Yogesh, you have anything or any inputs?
Yeah, means what I
I'll
understand is
just,
like,
I'll just pause it. Mhm.
yeah, what I understand is like algorithm is steps to do something, and
Mhm.
pseudocode is kind of a representation in which we will be executing those steps. For example, like a program what we
Mhm.
write in a particular language is one way of writing an algorithm, which is to follow the steps. Whereas pseudocode is like it can be in English language or can be like a flowchart as well.
Okay, if you're talking about the flow chart, then what exactly it means? So in terms of, yeah, I'm aware of that. We do have, the things in flowchart. We can have the decision making box, or we have normal box. But as we are concentrating mainly on the pseudocode and the algorithm, then what is your understanding? Yeah, you are right. That okay, but I don't want to go inside the flowchart. So basic terminology, if you can say.
Pseudocode is like normal steps what we will be writing in our for example, if I want to make you understand what I am thinking about algorithm, I can write in basic English steps, English sentences, like I'll do
Mhm.
this first, then second and third. And when I'm writing a program for that particular same algorithm for a computer language, then it will be following those syntax. So probably the syntax will be different. Means it's easier to understand for people like yeah, communicating
Okay.
this.
Yeah, good. So everyone is right over here. So I will just make you one simple, sentence. So if we are talking about, the algorithm, that is nothing but the semantic. Okay. And the pseudocode is nothing but the syntax. So whenever, let's take, I want to, okay, the first part, yes, I agree. Okay, can I have that? Okay, I will just share you, because the thing is my bandwidth is not good, so that's why I need to share the application one by one. Okay, I can just, okay, can you see my paint window?
Yes, it's
Okay,
visible.
so the thing is, let's take, if you want to develop one new product, okay, then first step is to write the algorithm. Okay, algorithm is nothing but the step by step, just the English language, what exactly you need to perform. Okay, so algorithm means your whole system is there. Okay, let's take, this is the paint. I want to, I'm as an end user, I want to use the Chrome window. Sorry, this paint. Then how do I do that? I just click on the start window. I search for paint, and it has been opened. So kind of, we just need to write a step by step procedure, what exactly the process or this product will do. Then here it comes the pseudocode. Okay, so pseudocode generally, okay, 1 minute. Pseudocode is just like, the representation of your algorithm in terms of a syntax. So these two are, if we are talking about these two, these are definitely, I would say, a language independent. Okay, these two are language independent. Then the next step comes as an actual program. So what generally program does, whatever you are writing, the first algorithm and the second one is the pseudocode. So based on the pseudocode, it is performing a program, means it comes the actual language. What exactly is language? Bit, if you want to use, oh, okay. Before that, are you comfortable? Sorry, are we comfortable in Java, JavaScript, .NET, or can you just tell me?
Java is fine.
Java, okay. And JavaScript, okay, Java and JavaScript, there is no much difference. Only the thing is, not much difference means there is a difference, but the thing is, if we are talking about the flow wise, only the internal methods are different. You can take any language, okay, .NET or Java or JavaScript, okay. That is the scripting language again, Java, but it does have the objects in it, okay. So the thing is, instead of using the IDE, that is Eclipse or IntelliJ, whatever the IDE, I just wanted to, for demo purpose, I wanted to use Chrome. Okay, the Chrome is very powerful, I would say, engine to demonstrate your JavaScript code. So if we are talking about the JavaScript, I want to, console.log. I can do anything over here. Okay, so I just wanted to print Gajanan over here. So Gajana has been printed. I want to create the function. Okay, function means
we can see only the paint application as of now.
Okay, no problem. I will just first I will do the paint and then probably we'll move to over there, because the thing is, if simultaneously if I share whole screen, no, the bandwidth is a little bit slower, so that's why. Okay, sorry for that. Okay, then the first step is algorithm, then move to the pseudocode and then program. Then third step means the fourth step is nothing but we have to write 0 and 0 and 0, and that is nothing but the bytecode. Okay, that is a machine level understanding. Okay, so whenever we are developing that is a high level language program, it has been converted into the bytecode, and finally it comes as a CPU, that is a processing unit. Okay, so whenever our program is maybe I just wanted to give you, have you ever worked on AWS?
No.
AWS cloud, it's anybody?
No, not yet.
Okay, no problem. I will just give you high level insights. Not okay. So whenever, let's take, I have created one program. Okay, I have created one product, and that product has been, I wanted to host it in AWS cloud. Okay, with EC2 instance. So the thing is, AWS does provide a different services that you can host your application. You can just do a load balancing, everything. Okay. So why I'm relating this CPU with there? So the thing is, whenever you are developing any product and you wanted to host it in AWS, so when configuring AWS, it will ask for the first thing is the space required by your application. Okay, and the second it comes the memory. Okay, so memory along with the clock cycle as well. Have you ever heard about the clock cycle? Yes, everyone, but it's in your syllabus, or maybe frequency, clock cycle, or frequency.
Just for my understanding, does the frequency relate to the number of instruction executed per second?
Yeah, exactly. So if we have 1 gigahertz of frequency, then to to load the instruction or to execute the instruction, it generally takes 1 nanosecond. Okay, that is a high level understanding, but we are not bothering on that. But at high level, whenever the time complexity and the space complexity comes into the picture, so these are the things that we have to keep it in mind. Okay, whenever you are hosting application, how many users are using your product, that is first thing. So based on the product or utilization, let's take, just like I have given the example of the search engine, 2 billion requests hits daily, right? So it will not go to the single server. We do have the instances of the servers. There we do have the load balancing. So based on the load balancing, it will just throw the request based on whatever uh, the instance is free, kind of. So these are at high level, but this is the flow when we are talking about the analysis. So we have to keep everything is in mind. Okay, so we have just started with algorithm. Okay, but there are lots of steps to go. But if we have the fundamentally strong, then definitely the other things are in our way. That is the high level understanding. Then I will just share the screen, then share the application now. Yeah. Okay, so I just covered this thing. Okay, so how efficiently you solve a program. Okay, so let's take, okay, I have one program. Okay, okay, I will try to share whole screen first, because I wanted to switch between different windows. Okay, what I need to do, just okay, check whether character C is exist or available, exist or available in string str. Okay, so this is the problem statement. Okay, can you please write the algorithm or the pseudocode for this problem statement? We'll just do it parallelly as well. Have you got my point? So this is the program. Okay, this is very simple. We have a string. I will just okay, irrespective of language. Okay, so just write a function that I will just give you the method signature as well. I need a boolean is as a return has letter, and I will just pass string str and char c. Okay, so this is my signature, method signature. Can you please complete the the first thing is please try to write the algorithm. Okay, after that we'll move to pseudocode and then we'll move to actual program. Okay, so can you please try to write the algorithm and the pseudocode for this? There can be many possibility that you can, based on your logic, you can just write the program. Is this fine with you?
Yes.
Okay, and please don't Google it, guys.
So what do we need to do? We need to write the answer in the chat box, or
Yeah, you can write it over here as well. You can just send me once you are done with the algorithm. You can paste it, and if you are done with the actual code, that is also fine. You can just write it over here. Okay, good. Look through individual characters in the string and find. Okay, str to then. Okay, return false, return false. Okay, perfect. So the thing is, okay, I will just this is, I would say, I will just Okay, I will just share my screen again. Okay. Can you see my window?
Yes.
Yes.
Okay, so the thing is, we have to check C whether the character C is there or not. So yeah, this is a simple program. Then we are talking about this best case, worst case, and average case. Okay, so if the best case is there, then we can say best. When we can say the best case, in first iteration we are getting this Gajanan, matlab means G. Okay, so in first place, let's take Gajanan as a string, and we have to find G from the Gajanan. Okay, in first iteration we are getting the G, so we are just returning true to the method, right? So it will not execute the other loop. But the worst case scenario, let's take the computer is the name of the string and we are searching for Z. So what happens generally? It will iterate through this loop till the length of this string and it will throw that false. Okay, so that is nothing but it will iterate 8 times. 1, 2, 3, 4, 5, 6, 7, 8. It will iterate 8 times, but it will return false. So that doesn't make any sense, right? So the worst case in the sense, if we are talking about, if the character is not inside the string, or maybe we can say if R is there, okay, sorry, if R is there, then it can be the same thing, right? So we have to iterate through each and every character, and then finally we are getting the R in last place. That is nothing but we can say this is the worst case scenario. But if we are talking about the average case, let's take, we have to find the U. Okay, so for finding U, we have to iterate four times, and then we are getting this U, and it will return a true to U, right? So the thing is, the best case is always be preferable. Worst case is nothing but, again, this is the upper one. We'll see again inside the notation things. Okay, so the best thing, worst thing, and the average thing, average case. So this is really very important. Okay, so we have to write a code in such a way that it should be very efficient. Okay, so when we are talking about the performance things, and let's take, okay, we'll just take, I think I have just noted it down, Rohit questions. Okay, why recursion is needed over iterative? Okay, so do you have any idea, guys, why it's needed, recursion is needed over the iterative?
It reduces the boilerplate codes.
Okay.
Please, could you repeat the question?
Yeah, sure. So why the recursion is preferable over iterative? That is the question from Rohit.
Okay. So we need to answer if we can.
Okay, the first thing is whether it's a right sentence or right question or not. If right, then why? Why we are preferring, the recursive over the iterative? If not, then why it's a wrong question?
It depends
Okay.
actually. It depends
Yes.
on actually. It depends on the things where we want to use
Mm-hmm.
what. For
Yes.
example, in basic programming, when we go, the memory is stored, like, right, the data variables and everything is stored in heap, stack, and everything. So whatever functions we are writing, they are in a sense of a recursive kind of a thing. They are into function. One function calls back. Again, the pointer goes there. So our computer programming is using recursion. So in complex things where we need, there are benefits of recursion. And when we are writing a simpler programs, or just like finding a particular element or a alphabet in a string, then we can directly use iterative algorithm as well. So it depends actually on the application where we want to use it.
Good. Good. Thank you, Yogesh. Biju, you have any points on this?
No,
Okay.
I have to go through those segments. I have not yet go on to that.
Okay, no problem. So, Rohit, as Yogesh said, right? So it totally depends on the scenario. So it's not like that why we are preferring recursive over the iterative. Yes, many of the times it happens that we have to prefer the recursion over the iterative. But the thing is here, if you see, as you are a Java background, right? So we have the memory segment, right? JVM has divided into the 5 memory segments. We have the class area, we have the heap area, we have the stack area, we have program counter and other things. Okay, so
Okay.
whenever we are talking about the recursion and the iterative, yeah, it totally depends on the scenario, right? So let's take, if I want to do iterative things, right? So how many variables you are initializing and how you are configuring based on the logic. Okay, so if we have, you are initializing, you are doing a many manipulation inside the iterative and you are doing it, so that is not the good sense, right? So whenever we have the recursion, we are calling the same function again and again, and we can reuse the function anywhere else. Okay, so recursive in the sense, the same function, we are just like, let's take, okay, I do have one example. Okay, the first thing is you are reducing the code length size. Okay, the second thing, I will just share with you. Okay, where is it? Okay, so can you see my screen, notepad?
Yeah, I can say.
Yes.
Okay, so if we are talking about the iterative, so this is the iterative Fibonacci series. Okay, so here we have to, initialize these two variables. We need to do it. Yeah, the logic is again different, but if we are talking about the basic programmer, then he will do all these things. But inside recursive, we are calling the same function again and again, and we are reducing the size, and there the result will give the same result. There can be, there can be a time complexity difference, not at high level. Okay, so it's just a minor means in terms of many nanoseconds kind of. Okay, it's very negligible. But the thing is, based on the scenario, you have to, take a judgment that where we can use the iterative and where we can use the, sorry, where we can use the recursive and where we can use the iterative function. And whenever you are calling this one, these functions will store like a stack, okay, in a memory. So if we have the same function, we are just calling, we are just changing not signature, the parameters to it. But here we have to initialize everything, we have to do a for loop again, the assignment operator and these things. It will definitely, it will take, I would say, not a processing time. But again, this is not the perfect example. Okay, I can't say this is the perfect example, the difference between these two. But here, let's take, if you have the iterative function which take, 1,000 lines of code, but if you are using the iterative, it might, reduce to 800 as well. So these 200 lines of code will have the assignment operator will have, some calling function, some memory occupation. Okay, so these are the things. So based on the scenario, we have to choose whether we will go for iterative or, the recursion. Are you clear on that, friend?
Yeah, this I had understood, like it reduces the number of line of code. But while in the session, I read that for the non-recursive way, the first way, the time complexity and the space complexity both are constant time, like O of 1. But for the recursive way, it is O of n. So like in that way, the recursive
No,
takes
no.
more time.
You read somewhere, or how is it?
Yeah, in this session only, in upgrade session, like just.
Okay, I
Like
just need to go
I
through this section.
Gajanan, I want to ask one thing. I had
Mm-hmm.
went through the complete session. So initially,
Mm-hmm.
I was also thinking that recursive program takes the time complexity of as exponential because it was mentioned somewhere in the beginning of the session, in the initial of the sessions. But when I reached till the master theorem and those part, I came to know the recursive programs also have different types of time complexities. It's not
Exactly.
necessary recursive program is having exponential or higher time of complexity only. So it actually depends how we are using that
Exactly.
recursive algorithm as well.
Yeah. So down the line, we do have the questions. I do have the complexity examples as well. Okay, there we have the recursion as well. So maybe recursion is there or not, I'm not sure. But the thing is, yeah, definitely this is not the case. Whenever you are going for, the recursor, it's always, the time complexity one, that is really not. So again, it's depend upon what exactly you have written in your code. Okay. So it always change based on your code, what you need to
Okay.
write and how you want to implement it. Okay, and it's not like that you have to prefer recursive over the iterative. That is really a wrong statement. Okay, so based on scenario, you have to choose whether the iterative or the recursion. Okay.
Okay.
Okay, then we have seen this. Now, yeah, here it comes. What is meant by time complexity and the space complexity? Okay, again, this is, it's a generalized statement that how much time does your code takes to run completely. Okay, it defines as a number of steps required to solve the problem. Okay, what we'll do sorry guys, we have some of the codes down the line, and we'll just see what exactly the time complexity and the space complexity. The space complexity, guys, please be clear on this front. Okay, space complexity is not only with respect to space, it with respect to memory as well. Okay, it is defined as the amount of space and memory required by the algorithm to solve the problem. It's not only with respect to space, even though it's a space complexity, but the thing is the space along with the memory it comes. But usually we say how much space does it require. Okay, so please keep it in mind that we need to take care of this memory as well. Okay, so these are just the time complexity and the space complexity. Based on that, we are just checking the efficiency of your program. These are the part of algorithm efficiency. Now we'll move to the big O notation. So big O notation means what exactly? There are different notation like big O notation, omega notation, theta notation, right? So big O notation is the upper bound. That is nothing but we can say whenever we do have the worst case scenario, then we'll go with big O. Okay, I'm not concentrating on the other notation, that is the omega and the theta. Omega is nothing but whatever your, I would say, that is the lower bound. Okay, so lower bound in the sense below that you don't have any operations over there. Okay, and big O is nothing but the upper bound. Above that there is no any operations. Okay, and again the theta is nothing but in between. In between in the sense we do have two instances like C1 and C2, and it lies the operation between these two. Okay, so these are the terms. But the thing is, whenever you are approaching for any interview like the Google or Amazon, okay, so there they will ask for the time complexity, then definitely by default it's a big O. Okay, that is a worst case scenario. So how usually we calculate the complexity? The first thing is we are listing down the basic operation in the code, count the number of times each get executed, and sum all the counts to get the equation in terms of n. Okay, so these are just steps, but down the line we'll see how to calculate it. But yes, before that, these are the standard big O notations, or I would say the functions that we usually use in our daily life. Okay, so if we are talking about the function 1, that is O of n, that is the constant. Okay, so what does this means? What does this O of 1 means? Okay, so this O of 1 means, let's take irrespective of your input size. Your input can be anything. Okay, so based on your input size, it will return you the same result in one go. For example, I will just move over here. Can you see my Chrome window?
Yes.
Yes, we can see it.
Okay, so I wanted to just have is even or odd. Okay, so this is my question, this is my function. Okay, what I will do, I will just pass n. N is any number. Okay, and what I will do, I will just return what I need to return, n mod, sorry, whether it's even or odd, it's equal 0. Okay, I can just this, I will use the ternary operator. Okay, even odd. Okay, so this is my function, is even or odd. What I will do, I will just pass the values to it. I will just pass 3, that is odd. I will pass 4, that is even. I can just pass anything. Okay, kind of, it's giving me even. So the thing is, in first go, if you are getting the result in first operation, if you are getting the result, that is nothing but the constant of 1, constant, that is big omega of 1. Okay, so this is very basic thing. Okay, so we can say, if we are talking about what is sometimes if you approach for the gate examination or any PSU's examination with respect to the computer science, then definitely they will ask for which of the below time complexity is better. Then if we are talking about of 1, then definitely in first go you are getting it. So this is the highest I would say time complexity. Okay, so this is the constant. Then we'll move to basic. Okay, so I do have different programs. Okay, I will not spend much time. I will just copy paste it over here. So the thing is, let's take, I want to see, I will just explain you this code as well. Okay, so this is nothing but find max. What we need to find max. Let's take, I do have one array, and from that array I need to find the max number from it. Let's take, this is the max. I just initialize it. If we are talking about the Java, then we do have the int max is equal to 0. We need to initialize it. This is the counter to just see the count, how many times this loop is executing. This is the for loop. N is, see, in JavaScript, okay, whenever we are talking about the JavaScript, this n is any in the sense we can use as a string, we can use as the integer, we can use it as an array, anything. Okay, so here we are considering this, we are getting as an array. Okay, we are just taking the length of this and we are just incrementing the counter. And this is the max. Max is nothing but we have already declared, but there is no value, so that's why it is by default undefined. Undefined is nothing but null, not null, kind of, it doesn't have any value. Null is also value considered in JavaScript, but undefined is nothing but there is no value associated with max. Or we are just taking n of I. Let's take n is nothing but, n of I is nothing but the array of first value. We are checking it and we are just finding the max over here. I will just execute this code. What I will do, I will just do find max, and oh sorry, and I will pass an array. So in JavaScript we'll just pass array like this. Okay, and algorithm, JavaScript and algorithm, these are, you know, the language independent, so we can see it over here. So find max is nothing but this is the array for us, and n is nothing but, you can see the length of your array, 1 2 3 4 5 6 7 8, and the counter is running 8 times. So that's why this for loop is, you know, working or iterating 8 times, but finally the max is 9. So what I will do, I will just change it somewhere. Okay, and I will hit it over here. So here if you see, the n is equal to 3, max value is 4. Okay, so this is, you know, this just a basic example of finding a max number. Then how do we calculate, you know, the time complexity for this? We'll just take this one and we'll just copy it in the notepad. Okay, so what we need to do, we have to calculate the time complexity. Okay, how do we calculate it? So don't bother on this front. Okay, the console and the counter is just only for our purpose. Okay, okay, so as we already saw, right, time complexity. Okay, time complexity means the number of operations, or we can say how much time this code will take to operate it. Okay, we'll take, let's take, this is the operation 1. Okay, and this is operation 2, means it is executing only one time. Okay, this is operation, again this will 1, means it is executing one time, it is executing one time. Inside this loop we do have two operation. Okay, again this will execute, we'll see it. Okay, this is one operation and this is another operation. Okay, means there are total two operations inside our loop and there are two operations outside our loop. Okay, so what we can do, inside loop what we have, two operations. Okay, two operations, and outside loop how many operations we have, two operations. Okay, but guys, okay, the main thing we need to understand is for loop. How many times does it execute? N times, right? So whatever the value of n, if you see over here, let's take, if we have the length of 8, okay, it is executing 8 times. Okay, so for loop it will execute n times, means it's, if you see, this is 3 times it has been executed, this is 8 times has been executed. So whatever the value of this array, the count of this array, So that is nothing but n. And the calculation of the total time calculation or total operation, how many operations we have performed, we can say, see, the thing is 2 is outside, okay, but inside loop, how many we have? 2, but how many times it will execute? N times. Okay, have you got this? See, the thing is, I will just make you clear on this front, because the guys, this is very important. Okay, so this is my code. This max will operate only first time. Only first time means only one time. This return will happen only one time. But we do have two operations inside for loop. This is first operation. This is second operation. Means there are total two operations inside our loop. Okay. But this loop will execute till n. N is the length, right? So whatever the length of an array, so it will execute till that length. Okay, till that time. So for loop, I would say length, okay, is n. So inside for loop, how many operations we have? Two operations. So what we can just say, okay, we will do n into 2. That is nothing but n is nothing but length. And how many operations are there? Two operations. Okay. But plus we have two operations outside as well. So here also, here one operation and here one operation, right? So we can just add 2 to it. Okay, then how we can say that 2 and plus 2, right? This is the total operation. Okay, this is the total operation. Now we do have asymptotic analysis, right? Asymptotic analysis. What exactly this analysis means? So let's take, you have right now, I will not go with the theoretical term. Okay, so you have 8, the length of array, you have 3 as a length of array. Let's take, if you have infinite length of an array, then how your complexity you will calculate. So that helps the asymptotic analysis. Okay, the asymptotic analysis, it usually look for the infinite numbers, infinite inputs, if your algorithm is there. Okay, and how it behaves when we have the infinite inputs. Okay, so based on that, it will just try to help to calculate our time complexity. So what happens generally, let's take, if I have n is equal to 10, then what generally happens? 2 into 10 plus 2, that is nothing but what we will get? 22. Likewise, if I increase the n size, that is 100 plus 2, okay, what happens generally? 202, right? Likewise, if I increase like 1 million, okay, 1 million plus 2, okay, so whatever we will get, that is 2 million 2 kind of. Okay, so these are the things. Okay guys, please be clear on this front. Okay, so this 2 is negligible, we'll remove this, because the thing is ultimately we need to find it out what are the the crucial parameter it is impacting the expression. Okay, so these two we can remove easily. Okay, the main thing is your n. Okay, if the value of n, it's so everything is manipulating based on n. Okay, so this 2 is negligible, and this 2 also we can based on our 2 is common. Okay, that we can consider as a c, as a constant, but this n is impacting your expression, impacting your algorithm. So that is why the main core of your analysis is nothing but it is impacting n. So for this code, we can say the time complexity is nothing but big O of n. Okay, did you guys get this point?
Yes.
Okay, thank you so much, guys. Then we'll move to the next one. That is nothing but, sorry.
So, yeah, can I ask one question there?
Yeah, sure.
So here, we have the loop runs till n, right?
Yes.
Say for example, we have a constant value, like say high less than 10 there.
Sorry.
like instead of the loop running till n dot length, so we have a constant 10. Okay. So in that case, no, still the program is going to, the complexity is going to remain the same, right? But why are we saying it is O of 1? That was
Okay.
my question.
Okay. So the thing is, okay, the first thing is a time complexity is the generalized term. Okay. So whenever if somebody asks you to calculate the time complexity of that, then we can do like this. Okay. So if it is working, okay, I will just make it clear you. Okay. Outside the loop, we have two operations. Now inside our loop, how many operations are there? Two. But this loop will execute 10 times. Loop execution. Okay, loop execution is 10 times. Then what we can say, we do have 10 into 2 plus 2. That is nothing but we do have 22. Okay, so what we can say, we do have O of 22, means within 22 I will definitely get this one. Sorry.
Okay.
Okay, this is the worst case. Okay, this is the worst case. See, whenever we are talking about the big O is nothing but the upper bound. That is the worst case. Okay, so if we have this 10 and we perform like this, so this is not the standard thing. Okay, we do have some software standards. So whenever we are talking about the big O notations, then generally, let's take in real time scenario, will not use 10 as a hard coded value over here. Okay, down the line we are getting some inputs from one of the users, or maybe I would say from any other application. So as a software industry standard, we have to make your code as generic as you can, that it can be used by somebody else as well. It should not be the hard coded thing. That is the standard of your software development. Okay, so this is not wrong. I would say this is not wrong. Okay, if we are talking about this code, if you say O of 22, that is perfectly fine. But the thing is, as per our industry rule or the time complexity standard, we do have only this standard. We have other as well, but we have this standard. So we can say that O of n, that is nothing but we are considering, that is the asymptotic analysis. We are saying that when we have the infinite number of time, how our function will perform. Okay, we have to take not only with respect to the 10 values or 100 values. Let's take your code should be as much as robust as number of infinite values. If we are given to this function, whether it is sustainable or not, that we are finding it. That is the main core of time complexity. Does it clear your question?
Yeah, yes. Yeah.
Okay, thank you. Then we have I do have the the quadratic thing as well. I will just copy it because I wanted to demonstrate it, but the thing is, due to the less time, I just copied it. Okay, now the third thing is we have to has a duplicate. Duplicate means what we are trying to achieve over here. Whenever if we have let's take, I do have an array and I want to check whether the same number is duplicating within the same array or not. Okay, what I will do, I will just enter it over here. So for that, I just created a constant array. This is just a counter. This is not required. Okay, and we do have the for loop and another for loop. That is nothing but we are iterating over the same array. Okay, if we have the same thing, that is outer is equal to inner, that is nothing but our first thing, or maybe we are doing over the same array, right? So if the same value is coming at same place, that is this is not the duplicate case. That's why we have written it as a continue. And second thing, if we are getting some other in other place, we are getting the same value, then we are just returning 2 over here. Okay, so I will just demonstrate it. Two, three, four, five, 7, 2. Okay, sorry, what is that? Okay, I just missed it. Okay, so here we are getting true. That is nothing but we have got this thing. That is nothing but 2 has been duplicated. Okay, so that's why we are getting it as a true. So let's take if I want to calculate the, I would say, time complexity for this, can you just tell based on your understanding what would be the time complexity for this and why?
It is n into n since we are looping over n on the outer loop as
Okay,
well as on the inner loop.
sorry, who said this?
Biju, yeah.
Biju? Okay, good. Yogesh, you have any other inputs?
I also think it's O of n square
O of
because
big
both
O
the
of n
loops,
square.
yes, because both the loops are ranging till there. So worst case, it might not be equal. So it will go till the maximum limit of both the loops.
Okay, that's really good here. So there are some, we'll say loopholes. Okay, so whenever we are talking about a time complexity, you can just take a judgment that here two for loops are there and the length would be the same. Then definitely it's a n square. That is big O of n square. Okay, so okay, before I will just write one program. Okay, so you can just tell me what would be the time complexity for int I is equal to 0, I less than n, I plus plus. Okay, here j, j, k, k. And what I am doing over here, if okay, first thing is in function, let's take ABC. Okay, here I am declaring let what I would say x is equal to, okay, x, let y, let z, 3 into x plus 8 into y plus 9 into z. Okay, if it's equal, let's take 91, 92. And okay, so guys, can you see my code?
Yes, we
Yes.
can see.
Okay, and return false. Okay, so let's take what I need to do. So this x, y, z, I'm not sure what would be the thing. Okay, so I just wanted to iterate over here, or maybe what I can do, sorry, I will just put I to make it simple. Again, assignment, I don't want to do it. And okay, okay, just remove this. Okay, so this I, J, and K is there. Okay, and I want to see whether this equation, this is the polynomial, okay, this is satisfying this condition or not. If it is satisfying this condition, then I need to return as a true, otherwise I need to return as a false. So the first thing is whether this will be a right syntax for the code or not. Maybe you are from Java background, no? Okay, did you understand this JavaScript or not? No?
Yeah, we understood the code.
Okay, let me write it in Java. Okay, test it. Okay, एक, दो. Okay, I forgot about this thing. Okay. Hey guys, can you just have a look and can you just tell me what exactly it will print? And what would be the time complexity for this? Whether this will compile or not.
Yeah, this should compile.
Mm-hmm.
The time complexity will be like n cube, n into n into n.
Yes. Here the main thing is our time complexity. Yogesh or Rohit, who
Yeah,
is talking?
that, yeah,
Yeah.
Yogesh. That's what I was
Yeah.
also saying.
Okay. So you can say, see, the thing is, this is very basic funda. Okay. So if you see the loops which are ending with n, then definitely you will get a time complexity of how many n's you have. That is n raised to how many loops you have. That is nothing but n cube. Okay. This is very basic thing. Okay. So this compilation we'll see it later because we don't have time right now. Okay. Now we have the other thing as well, that is O log n, on, n log on. So let's take what is exactly n log n, logarithmic. Okay. So before that, do you know log of 10? What is that? Can you just tell me the value? Log of 10, log of 100, log of 1000. Okay, I
Log
will
of
just
10 is log of
1.
10 is 1.
Log of 100 is 2, and log of 1000 is 3. See guys, this is very important. Okay, the n value, that is nothing but the input is 10, is 1, 100 is 2, and 1000 is 3. Means you are multiplying 10 times, but the logarithmic value is just changing one time. Okay, that is nothing but, if you see, okay, uh, based on the n values, the logarithmic value is not changing much. Okay, the best example for this is, I would say, the next one is binary search. If you are talking about this binary search, then what we are doing usually, okay, I will just mention, okay, in binary search, what we are doing, binary itself is saying like this. Okay, let's take, I do have to, okay, before that it should be sorted. Okay, then let's take, I do have 2 3, sorry, 2 3 4 5 6 7 8 9. Okay, how many items are there? Okay, and I will say 10. Okay, so what exactly the binary search is doing? The first thing is, this is an array which is a sorted manner. In binary search, what we are doing, we are dividing the first array by 2. Means whatever the array is there, array, we are dividing it by 2. Okay, if we divide this array by 2, that is nothing but 1 2 3 4 5 6 7, no, 1 2 3 4 5 6 7 8 9 10. Oh, 9. Okay, so we have total 9, and 9 divided by an array, that is nothing but, how we can say, it's 4. Okay, so what generally happens, we are checking first time. Means let's take the, I would say, in binary search, I want to search 8. Okay, then what happens generally? First thing is we are dividing into 2. Okay, then we are getting the fourth location, means 0, 1, 2, 3, 4. So this is nothing but our fourth location, that is 6. Okay, and we are checking it whether, means array of 4 is nothing but, sorry, array of 4 is nothing but our 6. So whether this 6 is greater than whatever our expected, we can say expected is equal to a. Okay, so a is a variable, whether it's a greater or 6 is a small of a. So we are finding out that front, but the thing is lesser than a, that is nothing but the second condition. Then what happens generally in second condition? So we have to find from 6 onwards towards here. So whatever the value is there, then our array would be 8, 7, 8, 9 and 10. Okay, so we are just finding it, and again we are doing the same loop, that is a recursive again. Okay, we are doing a recursive. So based on that, in second go, if we are searching over here, we are dividing into, again the 4 is divided into 2. If that is the same thing, means array of 2, we are getting it over here, means let's take whatever the ER of 4, that is nothing but the array we have divided. So now if we have divided this array by 2 again, that is nothing but 8. Okay, so whatever our search string is there, a is equal to 8, and we are getting it over here in first go. Okay, before that, greater than or equal to, or 6 equal to a, sorry, 6 equal to a, that is also one condition. Okay, there are total 3 conditions. Equal to a means whatever we are finding, the middle would be the search criteria, search string or not, it is greater or it is smaller. Now in second go, we are getting the same thing, whatever we are looking for. Okay, so 8 is nothing but the search string, that is nothing but, if we are doing a linear search. Okay, linear search means what happens generally, one by one it is taking. Okay, that is the good question. Okay, so linear search, what it generally do, it will go with one by one. Okay, means it will search for whether it exists in 2 or not, or 3 or not. Okay, so what is the time complexity of linear? Time complexity of linear search. Here guys,
Yeah, for
time complexity.
okay, for linear search, it will be only n, but I think in this case we'll need n square. We'll need 2 loops.
Here you are saying that this is O of n.
Of n. No, I'm
Okay.
saying for linear search, generally I think it will be O of n, but I think here for searching this array, I think we need n square. We need to have 2 loops, so it will be n square.
Where here you are saying
No.
in binary search?
No. In the normal search, if you want to have loop and then search, this is my understanding. Based on my understanding, if you need to search individually, not using binary search, normal search, if you are searching,
that is linear search. Did you get my point? The linear search is nothing but it will search one by one, whether the selected string is, that is O of n.
O of n, yeah.
Now if we are talking about the binary search, what exactly we are doing? See, here the iteration would be whatever your n size, it is doing it. But if we are talking about the binary search, then we are, every time we are doing a half of that. Okay, that is the array. First time we have, the 9 size array, then we are, in second go we divided the array in next half, that is nothing but only 4 elements we have. And in third search we are getting the actual value every time. If we are dividing it by 2, that is a normal funda. Okay, if we are dividing it by 2, that is nothing but, if the whole array we are just dividing it. Okay, so that is why the log functions come into the picture. So whenever we are dividing, we are doing a half of that, then definitely it's a log function. Okay, so for binary search we have log n. So here we already saw it, right? So O of log n. So this is nothing but the logarithmic function for binary search. Okay. Talking about the equation, it will really take a lot of time to solve this. Okay. But the thing is, let's try to understand the simple thing that whenever we are dividing the whole array into half, then definitely it's a log thing. Okay, we'll see another example which relate the same thing. Okay, have you ever saw the merge sort? Merge sort, what we are doing it over there. I do have the thing over here, but just try to see the things. There are different things, right? Bubble sort, merge sort, insertion sort. Then what exactly this merge sort will do?
It follows
No idea. Divide and
divide and
conquer rule.
conquer.
Yes, yes,
The same way what
yes,
we do for the
exactly,
binary search
exactly.
as well. But I don't know the exact
Yes, and along
algorithm.
with that, okay, I just write it down over here as well. So if you are talking about this one, okay, so what generally happens, this loop execute n times, means when we are doing a merge thing. Okay, I do have the program as well for this, but the thing is, I just wanted to make you clear, guys, clear you one thing. So let's take, this is the for loop, right? And it is iterating till n, and we already saw if it is iterating n, then we definitely have O of log n, right? Till this, are you clear on this front?
Yes.
Okay, now just now we saw that binary search is nothing but we are dividing into half. Okay, and for that we do have the time complexity of O of log n, right?
Yes.
This is the binary search time complexity. Now if we have the merge sort and we are doing these two, then definitely it's a multiplication of n into log n.
Log n.
So that's why we can just say that n into log n. This is the time complexity of merge sort, that is nothing but O of n, sorry, n log n. It's very simple. If you're talking about, if you know the basics of this, if we see somewhere that it is divided into two, then definitely the time complexity for that is nothing but the log n. And if we see this for loop, then it's definitely run till n, that is nothing but the n. So that's why the time complexity for merge sort is n log n. Are you guys clear?
Yes.
Yes.
Okay. That is the thing, and there are lots of things, that is the quadratic, cubic, the other thing, exponential and factorial. So yeah, I just wanted to mention you this exponential, that comes the Fibonacci series, as we saw over here, right? The Fibonacci series. So Fibonacci is the recursive things. So what generally happens in Fibonacci, let's take, I just wanted to use again the same thing. So if we are talking about the Fibonacci series, where is it? Yeah, Fibonacci, that is the exponential. Okay, so exponential means what happens generally. I will take the same example. Okay, so this is the one, Fibonacci. Okay, so what happens generally over here, it is a recursive function, right? So let's take, I want to calculate Fibonacci series of 5. Okay, so 5 means what happens generally, we are sending a Fibonacci series over 5. This is the first thing. Then what happens, n is equal to 5, n is not less than 1, that is 5 is not less than or equal to 1, it will go inside a return condition, that is else. So it will, again, the first thing is fib of n minus 1. What happens over here in Fibonacci? Then the second thing is Fibonacci n minus 1, that is nothing but 4. Okay, 4 happens. And if we are talking about the memory as well, we'll just see the memory as well. Okay, sorry, this is the memory, and we just divide this memory. Okay, likewise. I'm really bad at the Pentium. Okay, so the thing is, this is our main program. Okay, main program, whatever we have, the main method. So from main method, we are calling the fib of 5. Then what happens generally? So fib of 5, n is equal to 5. Then it will go n minus 1, that is 4. But again, n minus 4 means again it will come to the fib n, that is fib of 4. Then here it happens fib of 3. Again it will go fib of 3. Again it will go fib of 1, means it will come inside, else it is doing minus 1, that is fib of again 2, right? It will come again, it's 2 is nothing but this one. Guys, please see the flow. Okay, and I forgot to add it over here as well. The first thing is main method. Okay, the second call is fib 5, that is in stack it will go like this. Okay, fib 5, here fib 4, here fib what is that, 3, here fib 2, and again we do have, if it comes n is equal to not less than n minus 1, that is fib 1. Okay, here fib 1. Okay, now this is fib 1, then it will go over here and it will check n is equal to less than or equal to n, then it will return n directly. It will give you n is nothing but what is the value here. It will not execute more. Okay, it will give you value, that is nothing but we are just removing this one because it has been executed successfully. It will come over here, we do have the value as 1. Okay, then it will go to fib 2, that is fib 2 is nothing but n is equal to 2. This has been completed. This is nothing but n of fib of 0. Fib of 0. Fib of 0 means again here it will return n value, that is nothing but again it will return 0. Okay, the fib of n is not, it will not execute. But again, if we are talking about the fib of 3, that fib 2 is already executed and we are getting the result over here. Now in fib 2 the left hand is completed. Okay, the left hand side is completed. Now the right hand side is nothing but 3 minus 2, that is nothing but fib of 1. So if we are talking about this one, okay, again if fib of 1 is nothing but again it will come over here and it will return you as a 1, kind of 1. Okay, so it will come like this. So if we are talking about the iteration and the memory stack, it will just remove one of them and it will place the other functions to it. So this is the kind of one pattern. Okay, what happens generally if we are talking about 0 1, this is the Fibonacci series, right? 3 5 8. Then what happens generally, the Fibonacci series, whenever you have, let's take, you have 2 operations. Okay, if 2 operations is there, then it will 2 raised to 2, that is nothing but it will perform 4 operation kind of. Now I just had 2 raised 5 operations, then it will execute total 2 raised to 5, that is 16 operation it will perform. Okay, that is 2 raised to 5, that is 16 right now. 2, yes, that is 16. So the Fibonacci series is best suited for this exponential function. Did you get this point, guys? I just left in between, but the thing is, if we are talking about the whole functionality, then approx 16 transaction it has been performed over the function. Okay, did you guys clear on this front? You there?
Yeah, yes.
Okay.
Okay.
Yes, I think this is the thing, and we have given with the example as well. I do have very nice examples. Means if we are talking about the factorial, then we can do with the permutations. So permutations means what happens generally. So let's say I do have A, B, C. I want a permutation of this one. then what happens generally, it will, the permutation start with blank. Okay, then okay, and then we have A, B, C, again we have AB, BC, AC, then the combination of all these. Okay, so that will come under the factorial. Factorial what happens generally, if we are talking about the factorial of 5, then what happens generally, 5 into 4 into 3 into 2 into 1. So this is nothing but the factorial of 5. So likewise, if we have this 3 combination, then 3 into 2 into 1 again, means there are different combinations we can perform it over there, right? So this is the best suited example for the permutations. Okay, and these are, you know, the time complexity, these are the generalized time complexity. But the thing is, if we are talking about, you know, with respect to the code, we have to see how many loops are there, how many operations are performing, the iteration of the operations, and you know, how many steps are there included in your code. So that is the main core fundamental of your time complexity. Okay, so majorly if we are talking about the, again, the space complexity, the you are aware of what is meant by space complexity and how does it calculate it?
Yes,
I think you are aware of, right?
yes. The same way the way we were taught about the time complexity in the session.
Okay, so I just wanted to, you know, give you a high level insights on the space complexity, because we are just running out of time. Because the thing is, this is very big session. It is not, you know, finished within 2 hours or 3 hours, because we need a lot of time to do it. But the thing is, if we want to, you know, go with a specific time, and I just wanted to, you know, touch the calculation of the space complexity as well. So let's take, I want to calculate the space complexity. So generally, for calculating space complexity, okay, space complexity, we do have a search formula, that is S of P. I would say S of P, okay, is equal to, we do have, you know, the fixed value in the sense fixed operation, and we do have the variable operations, that is, we can call it as a SP. So what happens generally, so let's take, I just wanted to give you like one function, okay, function ABC, okay, and it is taking a b comma c, and I just wanted to return a into b into c um, plus a plus b plus c plus 40. So can you please tell me what is the time okay, space complexity of this one? So based on what condition we need to understand the space complexity? You guys are there?
Yeah, just thinking.
Okay, constant. Okay, so okay, before that, let me clear you this thing. Okay, so what is meant by fixed component and the variable? Okay, so if we are talking about the constants, that is nothing but the C. Okay, this function does have A, B, C. These are the constant. Okay, this 40 is also constant, right? It does not have any fixed variable associated with it, right? So we can say the space complexity for this function is nothing but we do have only 3 variables, 1, 2, and 3. So it has been measured in, you know, units. Okay, space complexity for this this program is nothing but just 3, because we only have 3 constant variables. Okay, we'll take one another example, that is function. Okay, I just need to do a sum of an array. Okay, I will just not go inside the depth of that. Let's take, I will use a for loop int okay, sorry, i's till n. Okay, do, what I need to do, I will just take, you know, sum. Sum is nothing but just I will mention 0, and here I need to do sum plus is equal to whatever the sum plus whatever the value of I, that is nothing but plus n of I, and we need to return sum. What would be the space complexity for this? Okay, I will just paste it in our code, sorry, in our chat. Can you guys see it?
Yes, we can see it. We got it.
Okay, this is just, you know, the random syntax I have written.
Its complexity will be also constant.
Complexity is constant, you meant to say?
Yeah, the way we had calculated as 3 in the previous one, here only one variable is being stored. So it should be one only. That is some variable. And everything is being added on that itself. So same space will be consumed will be only one for that one variable.
Okay, okay. Any other thought, guys? A
For me,
dot length is some. Yeah.
I think it will be 2. We have the integer variable and also the I as well as the array.
Yes, yes, yes. You are close to the answer. Yeah, guys, please try to understand. We do have, you know, the constant plus variable. Variable is nothing but, you know, it has been changing over the time. Okay, which value is changing over the time? That is first we need to understand.
Some.
Some. Okay. And
And
any
if
other
we
thought?
take the example of I is also changing because it's iterating, increasing from
Perfect.
0 to
Okay.
n.
Okay. Okay. Yeah, you are close.
And then we have the constant array. So
Yeah, it is an array. Okay, array is nothing but they do have infinite numbers, right? It can be. Okay, so I think we are running out of time. Let me, you know, go through this space complexity things, because we do have the next thing is we do have the MCQs as well. So there we need to spend 15 minutes over them. So the thing is the space complexity. See, guys, here, okay, what we can say a constants. How many constants are there? We do have sum, comma I, comma n. Do we have 3 constants?
yeah,
Yes. Okay, so we can say 3. Okay, but if we are talking about the variable component, okay, variable component, this sum is nothing but it has been stored. Okay, but the thing is the value is changing over the time according to the value of n. So n can be anything. Okay, so here if we are talking about the n, it can be infinite as well, right? Every time we need to store those values, right? It will consume that space whenever we have the n. So the thing is, here the fixed component is these 3, but the thing is that is the array, right? Sorry, array of n, right? This array is nothing but we have over the period we have a number of let's take an infinite number. So that's why what we can say, this sum will iterate how many times, you know, n times. But the thing is this n, a of n, that is the array, that is the variable component. Okay, it has been changing one by one. That is a variable component. That is why this n, sorry, the first thing is the fixed, that is c is equal to 3, and the variable component, that is s of p, we can say, or variable component, we can say it's n. So that's why the space complexity for this is n plus 3. We can say like this, the space complexity is n plus 3 because we are changing this array over the time. So that is the main thing how we have to calculate the space complexity. Are you clear, guys? Yes, no? Okay, perfect. Guys, what we'll do, I think that is from my side. Okay, this is just you know, I did it for the last session. can you just tell me what is the time complexity? Okay, before that, I will just, what is the time complexity for this one?
It's O of 1.
Guys, please have a look, and then probably you can just give me answer.
The complexity will be O of n, where n stands as 10.
Okay, perfect. O of 1. Yeah, Rohit, could you please explain why it's O of 1? Yeah, Rohit, you are raising hand, right? I think you, okay, sorry. You lost in between?
Yeah, actually, I got a call, so it got disconnected.
Okay, no problem. So can you please explain why it's O of 1?
According to me, the loop has a constant of it will run for a constant time of 10, so it should be order of
Okay,
1.
so I don't want to do confusion for you. Let's take this. And now,
Yeah, then it should be order of n.
Okay.
yes, it should be order of n. And let's take if I, you know, I did like this. Where is it? I, okay.
Then also order will be O of n,
Why?
because like the way we have sum of constants theorem, the similarly we have a multiplication one. Similarly, we'll be having a division one. So if n is divided by any constant, we can ignore that, because supposedly the theorem says n is a very large number. We took as a scenario n is infinite number. So if you reduce anything from infinite, it will still remain infinite. The only thing logarithmic
Okay.
n will come when we will be increasing or decreasing the step size. So here we are
Yeah,
not decreasing or
exactly.
increasing the step size. So it should be order of n.
So this is the, you know, the tricky question, I believe, and the log of n is the correct answer. So sorry, O of n, that is order of n is the correct answer. Why it's not log of n, Rohit? The thing is, n is, we are not stepping it down. Okay, so n by n, let's take if we have, you know, 1 million and we are reducing, okay, we have 1 billion and we are reducing it by 2. That is nothing but, again, it will come a value of n, right? It is not, you know, you are not doing a stepping down, as you know Yogesh suggested. So you're not stepping down, you are not dividing your whole array into two. The main array is there, you are dividing first two, but that is nothing but, again, n itself, right? So
Oh,
the,
okay, I
you
got
know,
it. I mistook it for the third part, like I plus plus. There, it should have been like I divided by 2. actually.
kind of, okay, thank you so much, guys. Now what we'll do, this is, you know, again, it's a very big thing to understand, but due to time constraint we need to wrap up our things. But the thing is, I think we have joined 20 minutes late, right? So that's why I just wanted to stretch, I stretched 20 minutes late. What we'll do, I do have one question, Aris. You can just uh, give me an answer, but ping me separately. Okay, so I will just, you know, I need to provide it to the host. I will just share with you, and you can, you have my, you know, WhatsApp number, right? You can just ping me the answers as well over there. Okay.
No, I don't have a WhatsApp number. Like
Okay, so I will just ping it over here. So it's already there in, you know, okay, no problem.
that group.
Yeah, so I just, you know, added over here. So you can give me an answer. You have 10 minutes more. Okay. And within 10 minutes, you have to give your answers. Okay. I will just share the sheet with you. And later, okay, but before that, can we do one thing? So, okay. So what we need to do, we have interview bit. Interview bit. You are aware of what is meant by interview bit? Interview bit questions. So I will just give you 1 minute. So what happens generally, those big MNCs are there, right? Amazon, Google. So usually they post their questions over there, or they will do, it's just like a Hacker Rank or Hacker Earth. Okay, you can simulate your program over there, and you can do whatever you can just practice over there. So I do have, couple of questions for you. You can just write it down, or you can just go over there, you can just sign up, and you can just solve that program. Try to solve this program. Okay. Sorry, where is it? It's a very, the basic code. Okay, I just need to,
So we have
this
to
is the
we
one.
have to log. Okay, we have to log in over here, or
Yes, for interview bit, this is the question, right? So reverse integer. So you have to reverse the integer. You can just go over there and try to solve the program. Okay, so this is really a good practice for you down the line if you want to, crack any of the MSCs, right? So these are the couple of programs I just wanted to give to you. If time permits, then we'll do it. Otherwise, I'll just give it to you. These are, a typical program that you might be, and one actually I observed one, kind of weird behavior. Maybe what happens generally in whenever you are giving a hacker rank or hacker test, let's take you are using a string class, right? You have created an object of that. Then whenever we just click on, we have created the object, and the object dot if we do, and control space is there, right? Whenever we are using with Eclipse, then we are getting the list of the methods over there. But this interview bit doesn't have anything. Means it really a very bad idea, I would say. But the thing is, the interesting is they do have a great questions, right? So major of the MSCs will pick the questions from here. So for good practice, you can just go with online compiler. Okay, online Java compiler, try to execute the code over there. Okay, and just try to paste it in your interview bit IDE window. Okay, that practice you can do it. You can go with any tutorial points, Java compiler or online DB, any compiler. You can go over there and you can just try to demonstrate the code over there, and you can paste it in interview bit IDE. It will ease your, the coding thing. So that I just wanted to highlight you one thing. Okay, then we'll move to, the assignment part. I will just paste the questions over here, and you can just, okay. Before that, do you have any questions with respect to interview bit, or how to use it? And
Not as of now. We'll try to use it, and then if any issues, we'll get back to you.
sure, you can, we have the groups as well, right? We have one group, so you can just ping over there as well. Okay, now we'll move to, yeah,
sorry, do you have any
no
timeline
problem.
before which we should complete this questions, 4 questions?
Interview bit.
Yeah, in interview, but is there any timeline or
No, this is your practice. This is for your practice.
Okay.
Okay, but we have MCQ right now, and it's 13:17. We'll start with 13:18, and you have 10 minutes. Okay, we'll finish it by 3:30 maybe. Okay, will it work for you?
Yeah, okay.
Yeah, fine.
So,
Okay.
so we have to reply in your WhatsApp number, right? Answers.
Yeah, WhatsApp number. Just type 1A, 2B kind of.
Okay.
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 I will just paste it over here. There are only 10 questions.
Okay.
Okay, and you have 10 minutes. You can solve it. It's 13:18. Sorry, 3:18. You can just have a 10 minutes, and you can just ping me on the WhatsApp. Okay. what you can do, you can just try to solve all the questions, and in one go you can just send it to me.
I think you're on mute. Then.
Oh, sorry. So actually, I will just try to give you, the hint questions that usually asked in the interview. So what I usually do whenever I, go for any interview, and let's take. So if somebody interviewer asks us usually the questions. So once the interview is done, I used to write the questions, what exactly they have asked me. Okay, I do have those set of questions. So maybe I will just try to sort it out based on our today's session, and I will try to put it in the group. Will it work for you?
Yeah, it will be helpful. Yeah, and
Yeah.
also if you
That
can,
would be helpful.
and also if you can share the complexity examples that you have in the notepad.
Yeah, I do have this
Would
one,
be
so I will just share with you. Yeah, definitely. Okay.
okay. Thank you.
Okay, thank you guys, thank you for your attention. Have a nice day.
Yeah, thank you.
Thank you. Yeah, bye.